Alright guys, so in the last video for the part 1 we did the RC low pass passive filter. So right now we are going to start on the concept of RC high pass filter passive filter, right? So as you know, the response of this circuit would be somewhat like this, that it allows you to have output frequencies and stop the starting frequencies below the cutoff frequency. Here's your amplitude and here's your frequency, right? So there would be like very less difference in the last circuit to this one. We would have an RC circuit, but this time we would have a capacitor in the series, and we will take the output across the resistor over here, right? So that is your Vin, and your output is going to be from here, V out. Now, in order to measure this part, we would again say that now our voltage divider equation would be V out would be equal to R divided by R plus XC, which is the capacitance, impedance of the capacitor times Vn, right? And your XC, you can say again, is what? 1 over omega C, which is 1 over 2 pi Fc. Omega is 2 pi f, 2 pi the frequency, and times the capacitance, right? So now let's have a look at that. If we have a very small frequency, for example 0, or if frequency approaches to 0, then this whole value would become infinite, right? And then if I put the infinite value in the denominator, this will give me this whole fraction as a very small value, approximately near to 0, right? Something divided by the infinity is like almost 0 times the Vn. So we can see that the output would be 0 for frequencies when approaching to 0. So in this region, as you can see, there is no output, right? So as we have the lower frequencies, the output would be 0. The next thing is that if I try to approach the frequency to the infinity, right? So if I have some infinite value over here for frequency, then this answer would become very low, which means that the xc would become approaches to 0, which means that this fraction would be just r over r, which is 1. And when you multiply vn with a 1, you will get exactly the same output as what the input is, right? So you can have the maximum output from the filter once you have established the higher frequencies, right? So this is how you can understand that on higher frequencies it will allow you to basically pass or to get the maximum output. With that being said, this is your normal circuit over here. So we're going to do a design question over here which says that we have a capacitor and a resistor over here, which is V out, and that is your V in. It is a RC high pass passive filter, right? And it is now given in this question, it's different from like the previous video. It is saying that now we have a cutoff frequency of 10 kilohertz, right? And we know that the resistance value is fixed at 10. So now they have just given us the value. Let's say, for example, FC, which is 10 kilohertz, right? So our task is to design and find the value of C and the value of R over here, right? So as we know, the cutoff frequency formula would be 1 over 2 pi R C, right? So FC is given over there as 10 kilohertz, which is 1 over 2 pi RC. So now we are going to assume some values over here for resistance and capacitance. And I would probably assume the value for capacitance over there, because I know that capacitors are like very differently available. But for resistors, we can actually make combination of series and parallel and all that, and we can actually achieve something. But probably in lab, we would have like limited capacitors, right? So I'm going to say I'm going to pick a capacitor value of, let's say, 0.1 microfarads over there. So if I pick 0.1 microfarad, the value for resistance that I'm getting now is give me a second. So it's gonna be 10 kilohertz times 2 times pi times capacitance of 0.1 10 power minus 6, 1 divided by answer. So I'm getting a resistor value of 159.15 ohms. So that is available in the lab, right? 100 and 150, and then some different combinations can work out with 159 ohms, right? So by this way, you have designed the R and C values, and you have designed an RC filter at a specific cutoff frequency of your nature. All right, so for this question, let's try to sketch the plot as well. So we would have these two lines. We would have dead over here, then it would increase, and then it would become like this. At the minus 3 dB scale from the top, we would say that that is your cutoff frequency, which turns out to be 10 kilohertz, right? Now, again, if you want to increase your sharp falling edge, for example, this one black line over there is like a negative 20 dB per decade, right? So if you want to achieve minus 40 dB per decade, or if you want to achieve minus 60 dB per decade, you like in the last lesson, you can actually just have more order of the circuit, right? So we designed the filter which is like this, which is a first order. So it will give me a negative 20 dB per decade, right? But if I cascade it with a capacitor and a resistor, so now it is a second order, right? So I will get a negative 20 dB per decade, which is a sharp decrease, or you can say sharp rise. So based on your design, the basic formula is that for every nth order times the negative 20 dB per decade is what you get the slope after the cutoff frequency, right? So if there is like sixth order, then it's 6 times 20 is going to be negative 20 dB per decade. So it is the key, it is totally dependent upon the designer that how much leverage that he have over here and how sharp he wants his cutoff frequency to actually be in a realistic circuit. One more thing that I would like to discuss over here is that since we know the formula, which is cutoff frequency is 1 over 2 pi RC, right? But in a cascade circuit, for example, if it's a low pass filter, RC, and then there is another R and C, right? So in such circuit, what would happen that as soon as we increase, so our values over here would change, and that would now cutoff frequency would become 1 over 2 pi root of, let's say that is R1, that is C1, that is R2, and that is C2. So that would become R1, R2, C1, C2. And similarly, if we have like three third order filter, which is a combination of three cascaded loops, then it will be R1, R2. So then for third order, it would be 1 over 2 pi R1, R2, R3, C1, C2, C3, and so on, right? That's how you can actually figure out the cutoff frequency for the cascaded circuit, and you can actually change the slope at which the cutoff frequency actually exists, right? So yeah, that's all we discussed in the tutorial of that class. Probably we have touched upon something more in detail, maybe a discussion point of view and all that, but this is what we did. So yeah, this is how you can design RC high pass filter using the passive components. Thank you so much.